The CanSat primary mission involves measuring temperature and pressure as the CanSat comes down through the atmosphere. We've dealt with in some of the other videos about how to actually do those measurements. So what I'd like to do here is talk a little bit about what the CanSat is likely to find when it is taking those measurements. We live in effect at the bottom of an ocean of gases. The whole atmosphere above us is made up, primarily 99% of dry air is made of nitrogen and oxygen. Then there's also a little bit of carbon dioxide, helium, neon and argon, and some other gases. When scientists study the atmosphere of the Earth, they divide it into layers, each layer having common features. So if we look at this diagram here, we can see that as you come out from the Earth, the outermost layer, which extends to about 500 kilometers from the Earth's surface, is known as a thermosphere. In this layer, you'll find only the lightest of gases, so oxygen, helium and hydrogen. The layer inside that is known as the mesosphere. This layer has the coldest temperatures, down to minus 120 Celsius. Sometimes directly after sunset on a clear night, you might notice wispy clouds on the sky. They're in the mesosphere. So if we look at the different drawing of the same thing, the layer inside the mesosphere is called the stratosphere. This layer is important to us on Earth because it contains the ozone layer, which filters out some damaging UV rays. The layer closest to the Earth is known as the troposphere. This extends to about, on average, 10 kilometers from the Earth's surface. This is the layer within which all weather occurs, and this is the layer within which the CanSat will operate. So this is the one we need to know most about. Here is a graph giving us some information about temperature and pressure in the different layers of the atmosphere. So let's figure out what's going on here. So this axis here is showing you altitude. So starting at the bottom, or at sea level, is 0 meters, and then we extend up in kilometers. So as we go up, we go through the troposphere, the stratosphere, the mesosphere and the thermosphere. Now, there are two different things graphed on this: pressure and temperature. The scale for temperature is shown along the bottom here, ranging from minus 273 Celsius up to plus 27, and pressure is drawn on this scale here. Again, it increases as we go left to right. So if we take a look at the temperature graph here, we'll see that as we move away from the Earth's surface up through the troposphere, temperature drops. Okay? So we can assume that there's a linear relationship between temperature and altitude. The higher we go up in our CanSat, we'll expect the temperature to get lower. If we look at the pressure graph, we'll see it's kind of similar. So pressure, as we go up from the surface of the Earth up through the troposphere, pressure drops. And again, it's nearly linear, it's a straight line. So those two facts will be very useful to us. So let's take a little closer look at atmospheric pressure and try to understand what's happening there. So this little graph here is showing you how atmospheric pressure works. Pressure is caused by the weight of the atmosphere pressing down on us. So the formal definition is that it's force per unit area exerted against a surface by the weight of the air above that surface. So if we were to imagine a little square of Earth here, the atmospheric pressure we would measure here is caused by the weight of all the gases of all the atmosphere that is in this tube directly above us. So the weight of the air in that column applies atmospheric pressure to the point X. Or to look at it another way, this little picture here attempts to explain why atmospheric pressure is lower at higher altitudes. So down here at sea level, the atmospheric pressure we measure is caused by the weight of all this length of atmosphere pressing down on us. If we move to a higher altitude, atmospheric pressure is caused by a weight of air as well, but it's by a shorter length. So we would expect atmospheric pressure to be lower at higher altitudes than at low altitudes. Okay, so now we know what to expect. Both temperature and pressure readings should increase as the CanSat descends to Earth.